right now. So we're now recorded. And so here we go. There it is. Kyrie's hair blinking in and blinking out. That is all we needed. Okay. So we're talking about real number properties. And guys, essentially this is just, there's stuff you can move around and stuff you can work with when you're combining things that sort of help us to do things in simplifying stuff in algebra. And they give them names. A lot of times I don't think you would actually need them to be written out and to be given a name. I think you'd be like, oh, well, I can just add these in a different order. That's fine. Or I can multiply them in a different order. You know a lot of this stuff. What we want to be able to do is to use labels for them so that we know what property or what rule will allow us to do one thing over something else. And there's sometimes that it gets really useful, but those get into some more complicated sorts of problems. Right now, we just want to introduce you with the idea of this. And these are things that work with any real number at all. So as long as we're okay with that, we should be good. So you guys ready? All right, here we go. We have three properties we're learning about today: commutative, associative, and distributive. Now, the one that I consider, like, we'll call this the rock star of the three, the one that you're going to see the most often, the one that the paparazzi will follow around and take pictures of, that is our distributive property. That is the one that you guys have been using forever. Anytime that you've done anything with algebra, this is what we go through. In fact, I'm teaching an Algebra 1 lesson today that involves the distributive property and introducing it to everybody. So that's something that we're going to be familiar with. And what I try to think about when I'm thinking about these properties is I sort of think about, what do we start with and what do we end with? So with a distributive property, generally we can do this with division, but it's almost always and exclusively going to be something where we'll have a number on the outside of parentheses. Then inside those parentheses, we'll have two things either being added or subtracted. And what the distributive property tells us is that if we have a setup like that, we then distribute that number from the outside to both things on the inside using multiplication. And so that's the reason why we have, in this case, C times A plus C times B. So it's the reason to remember distribution, because that's the way that this is going to work out. And the nice thing about this is it allows us to both go in this direction where we're going to be distributing something with multiplication to two things, but you can also go the other direction. There are times that we use this when what we call when we're factoring something out. If we see something in common with two terms, sometimes it's an easier thing to simplify to take what's in common out. Now for today, we're going to be multiplying almost exclusively. So when we do C times A, C times B, that's the way that that works. And so that is kind of the way that we want to go about working with the distributive property. Multiply, bring them in. And the way that I tend to think about it, to observe it, is you have parentheses at the beginning, and when you're done, you generally get rid of those parentheses by multiplying. And so a lot of times it sort of helps us to think about what we're going to be looking for if we want to identify the property. What did we start with? What did we end with? And that's sort of what we're looking at here. Now, here is something that I think will be helpful, but I need you to understand that this is an imperfect way to remember this. But every single year that I ever did this in school, they always taught the commutative and the associative properties on the same day. And so when they did something like this, what I would do, because we'd have to memorize them for tests and things, I'd look at them and I knew what the properties were, but I never got them, I never had them locked in my head as to remembering which one's a commutative and which one's associative, because it always happened on the same day. We always had a test on it right afterwards. So I'd memorize it before the test and then forget it. And if that's not something that you guys have done, then I am completely fine with that. And I appreciate you being able to commit these to memory. But I have a way that we can remember the difference between these two things. And we'll see sort of what happens. I want to talk about what they do first and then how to remember them. So if we look at the commutative, Ms. Morton actually made these pictures here, which are great. She's got that little bus there that says commute. And to commute means to move from one place to another. So if you're commuting to work, you're going from a place that you live outside of that community and you're commuting to the community to be able to stay there. And so it's basically just traveling. So if you look at the commutative properties of addition and multiplication, we have the same things, A and B. Commutative basically just means that if you're dealing with a plus or you're dealing with a multiplication sign, you can commute to either side of it. You can either have A first and B second, or B first and A second. The order of those two terms don't matter. when they're surrounding a plus or surrounding a multiplication sign, because at the end of the day, you're going to get the same answer. And so A plus B, B plus A, they're the same. And this is a lot of times something that you guys are just going to do in your head. When you look at something like this, if you see 2 plus 3 or 3 plus 2, you're going to say the answer is 5 just because you group them and you're done with it. A lot of times people get used to that. But the property that allows us to do that is the commutative property, because you're going to be moving from one place to another. So commute means to move. And there's this associative property. Now, I'm going to ask for a minute for Miss Morton to unshare her screen and let me share mine, because I like yours as the official one, Miss Morton, and I would prefer mine to be less official, to write what I'm going to write down on here, and then we can get rid of it, and you can write whatever neat thing that you would like to write on yours in just a second. So here's what I'm going to try. Let's see if I can get this to the camera and see if it will let me do it. Okay, there we go. I have not quite done everything that we need to here. So here, the associative property, it's important, but the other part about it that I want you to think about is sort of what's going on. I'm going to start with just a number set to sort of give you an idea. Here we've got 3 things. So let's go 4 plus 3 plus 2. Okay, if you're adding those together, guys, I'm going to guess that one of you or another one of you is going to say, oh, I can get the answer to that, I'm done. If you have gotten the answer to this right now, I'd like for you to write that answer in the chat right now. 4 plus 3 plus 2 equals, and then get an answer. And I'm waiting to see what we have.
Okay, nice.
Yes, I appreciate that. Everybody is rolling out a 9. That is what I would say. You did a very good job with that. Now, if one of you is willing to unmute yourself and explain what you did, the order you did it, somebody raise your hand. No, somebody just unmute yourself and say, what I did first was this, and then what I did second was this.
I did 4 plus 3, which is 7, and there's added 2 more.
Okay, so 7 plus 2 is that. So you did the 4 plus 3 first, you added the 2 more, got to your 9. Solid. That is absolutely one way to do it. Did anybody do it in a different order? Because I'm going to tell you what I did, and I think it'll be sort of, a lot of times when I look at 3 numbers like this, what we can't do is just say 4 plus 3 plus 2 and have that stored in our mind as an answer. Like there's 3 numbers, we add things 2 at a time and get an answer here. So what Gage did is he did the 4 plus 3 first, got a 7, added 2, done. That's great. When I look at something like this, when I have 4 plus 3 plus 2, I always look at the smaller numbers first and try to put those together, and then whatever that's going to be to combine them, I'd combine it with the top. So I did 3 plus 2 first, got a 5. You do that 5 plus 4, you also get 9. And so what we're saying with this is that it doesn't matter which way you group these. As long as you're dealing with all addition or all multiplication, you're going to get the same answer. But because we have to add things 2 at a time, we associate 2 things or 2 other things, and that's the way we go through this. Now, the word associate is great, and there's this handshakes here because we're associating 2 things, and that's wonderful. That is not how I have chosen to remember this, because somebody in college told me the commute thing and it helped me, and then they said how to remember the associative property, and I never messed them up again. Here is how. If you look at the word associative, you'll notice that there is a root word that we could use within the word associative. Generally, that root word that somebody would use would be associate, but that is not the root word that I am talking about. The root word that I'm talking about is right there, the ass. And the reason why I want to make sure that you're thinking about that is because when this person told me this, I'm like, what? And then she said, well, look, okay, so what you're doing with this really is just moving a set of parentheses from 2 things to 2 other things. If you draw a set of parentheses there, and then you think kind of about the fact that maybe you've got like legs that are here, what you've got right there is little cartoon ass. And that's kind of a way for us to remember that when you're moving the parentheses from one side to another, it's the associative property. Now, please do me a favor. If you're going to write this down, so it'll help you remember it. Most of the time, people don't forget about the associative property. If you're going to abbreviate this, please add the OC at the end of it, because this is indeed out of control. Okay, I am going to stop sharing, and I'm going to go back to the other official one, and I'm going to let Ms. Morton share hers. And Morton, if you'd like to help take you through exercise 2, that'd be fantastic. I did just remember, however, that I am recording this, which means, guys, it's going to be fantastic to put this all up for everybody. Okay.
Okay.
Rob.
All right, so parentheses change place. That's where we're at for associative. And you can draw your reminder if you'd like to. I'll maybe add mine later.
Great.
Okay, so in exercise 2, we are simplifying, which is one of the things we introduced yesterday. And we said, when you're simplifying, all you're doing is combining like terms. And we probably made it sound a little too easy. Because there are other situations that can come up when you are simplifying. That means you can't just combine like terms. So you might have situations where the order of things are a little bit funky and you can't combine them right away. Or the parentheses are putting some things together that means that you can't combine like terms right away. Or most likely, like Mr. Bechtel said, you will have parentheses that you have to distribute some multiplication before you can combine like terms. So we need to be able to understand the process of simplifying and use the correct vocabulary to explain that process. We are giving you as much information as we can today, but we need you guys to know very clearly that really we need you to know distributive property, and it's nice if you know commutative and associative. Okay?
I 100% agree.
Okay, so in this first expression, 8 parenthesis 2x plus 3, close the parenthesis, plus 5 times the quantity of 3x plus 1. That's a messy expression, much more complicated than what we saw yesterday in our notes. So they've already done the math work here for us. We just need to be able to explain the process that they went through. So they copied the problem correctly. We all know that that's important. Then they did this. What happened from here to here? Anybody?
Somebody.
Okay, this is distribution that just happened here.
It's so quiet, guys.
Because we took the 8 that was on the outside of this parenthesis, we distributed it with the 2x, and look at that, 8 times 2x, they distributed. They did it again with an 8 times a 3, right there. Then they did it again because there was another set of parentheses, 5 times 3x and 5 times 1. Now, they showed an amount of work here that I don't think anybody else shows in their real world. So we're gonna do this. Nobody does that. If they wrote down 8 times 2x, the next thing they're gonna write down is 16x. Okay? So what happened here? This is a tricky question because they didn't do commutative, associative, or distributive property. They just multiplied 8 times 2x and got 16x. Even though it's not one of the real number properties that we just talked about, it was still a fine, legal, good move to do in algebra. They just multiplied. Okay. Now from 16x plus 24 plus 15x plus 5, now they move down to 16x plus 15x plus 24 plus 5. What happened there?
What did happen there? Besides craziness. Actually, it's not crazy at all. What happened there? Ooh, somebody wrote something down. I saw distribute. I saw addition. There is addition, but I want you to think, how did things change from the one before to this one? What actually changed as we were looking at this? Did they get rid of parentheses? Did they combine anything? What did they do? I heard associative is thrown out there. And by the way, I appreciate you adding your extra letters in there. If we think about it though, is it actually associative in the case of something like this? Did we start with parentheses and move them? Because here I don't see any parentheses or any other parentheses. If I look, 16x and 16x stayed the same. Then there was 15x and 24. Well, those are different. It looks like we changed the order of something. We moved from the 15x and the 24, and we changed the order of those two because that 5 stayed put. What do we call that when we're changing the order of two terms, just flipping the order of them? Antonio wrote something down. He wrote for commutative property. It's absolutely right. When it's just moving around, you're dealing with commutative property, and that's all you've got to look at for something like this. Now, I will ask you, when you start looking through these things, there will be a time that we're hoping for you to be able to identify what property we're looking at. It is not the most important. Mostly we would just want you to use these properties to be able to do the simplification yourself. But it is nice to sort of recognize the changes and try to label what you're looking at. And that's sort of what we're trying to do here. So, Ms. Morton, how would you describe this next step?
I'm going to go a little off script on this one, and I would say that they are just showing that they were combining like terms that in a little different way, that they were combining their x terms together here, and then they were combining their constant terms here.
And I agree with that. The one thing that I would say that's interesting about the combining like terms, it uses one of these properties. That first one, it's like the distributive property in reverse. Now, we're not going to ask you to do this a whole lot, but if you wrote combining like terms for both of those, that would be fine and dandy, and we would be okay with that. But you could also say that they use the distributive property there too, because they took that x out of both, so it's like the distributive property in reverse. And that's the thing about these properties. They're good to know and they're good to remember, but they're also, you can describe it in different ways. And I think that that is both helpful for you, because it means as you're going to be going through it, you can use different ways to describe what you're seeing. But then for us, it also means that what we can do when we're grading this is if you wrote the distributive property, you'd be correct, because that is a way of doing it. But if you also described what you were doing as combining like terms, you would also be right. And I kind of appreciate some things about math, that there are more than one way to describe it, because it'll give you an opportunity to get the correct answer in more than one way, as long as you can explain what's happened. And that's kind of what we wanted to make sure that we could see with this one. Okay. We're going to move on in a sec, but I wanted to ask before we do that, we just had a whole page of properties that we talked to you all about, and then we identified some here. Let's just take a second and have you guys in the chat, as many of you as you can, to sort of identify where you think you stand on this stuff. If you think this made some sense to you and you're feeling pretty confident, like if you had these in front of you, you could do this on your own, you'd be fine, then you're going to put a 5. If you have zero idea what we talked about at all, and this is just words being thrown at you, put a 0 or some number in between. We just kind of want to get a feel for where people are at for this. This would be something, if we did a pair deck, there'd be like a great place for people to click on things, and we'd say, well, look where everybody is. But pair decks suck, and I hate them, and we'll never use them because they always blow up and don't work for me. So,
True that.
You know, I'm really glad that we're recording this. This is the best. I have both said a swear word, not the first time I've recorded that, and also I said that stuff like that sucks, even though that's something that other people have told us what to do. That's fine. Okay, if anybody else wants to throw in where they're sitting, put your numbers in, and if not, that's fine too. We're just trying to get a feel for this, and if you feel more comfortable throwing a message privately to Ms. Morton or myself, we'd be happy to take those in as well and see where that's at. And if you feel like you're struggling with this, remember, we're just introducing these to kind of figure this out, and the names of these aren't as important as being able to distribute or to combine like terms. And I think you guys probably do that fairly well. Okay, Mort, do you mind unsharing and let me share for the beginning of this next one, and then we'll go back and forth?
Sure.
Rock on. I also took attendance, I think, while that was going on. So we'll see how this plays out. Okay, so I'm going to share screen, and I'm going to go to the second camera, and we're going to see where we're at. So we are moving to the next page, and this is the last page in the notes that we have. We also recognize the amount of time that we have. So I'm going to try, if I can, to be a little speedy about this, but I want to make sure that you understand what we're doing as well. So what we have right here is the work that we did on the page before. We saw all of the steps of taking the first thing, we distributed, we combined like terms, we moved things where they're going to be, and we ended up with 31x plus 29. So we know that these things, I can make this equal to this by doing some algebra stuff. And in fact, that is one way you can show that two expressions that look different or equivalent to each other, is by doing all the work that we did to one side and making it look like another. And so when we use the phrase equivalent, what we mean by that is we mean that there are two expressions that don't look exactly the same, but we can either say that we can either take one of the ones, use the algebra rules that we have and make it look exactly like the other one, or another way to say that is I could plug any number into this one here and get the same answer if I plug that same number into this one right here. Now we got to do our order of work correctly, but it is something that lets us kind of figure this out. So equivalence is easily checked to see if it doesn't work by picking some number, plugging it in, and showing that they don't equal each other. What we want to do is sort of test this for our ability to see if it's going to work. So generally, when you pick a simple value, you're not going to throw in a number here like negative 273, because that would be something that would be, you could absolutely do it, but it's just harder to do simply. So for me, I'm going to pick 1. 1's a great number. You multiply by 1, it doesn't change anything. So I just want us to kind of look through this and say, all right, I'm going to substitute 1 into the first expression, see what I get when I evaluate it. Same for the second one. So let's remember yesterday when we talked about evaluating, when we replace our variables, the first thing that we want to do is write a set of parentheses. So I'm going to rewrite this, 8 parentheses 2, and instead of that x, filling in parentheses, there's plus 3, plus 5, parentheses 3, I'm going to put that, plus 1, close it. So this is everything here, and because I'm doing them at the same time, I might as well do this as well. I now have a place to put my variables, and I have other colored pens here, but I forgot to do all that. So right now, x equals 1. Let's substitute that in every place that there is an x. Okay, so now we evaluate and see if they get to the same thing. I'm going to do the easy one first because that's the way that I roll. 31 times 1, that gives me a 31 plus 29. If I add the two of those together, I will get 60. So what I'm hoping happens here is that I'll also get 60. So I'm going to do the work inside the parentheses first, and I'm looking at my time. Morton, I talk too much.
Happens.
It does happen. So 2 times 1 is 2 plus 3. 3 times 1 is 3 plus 1. Okay, so I did the work first inside. Now I'm going to add those. This will be 8 times 5 plus 5 times 4. And now I've got to do the multiplication here. 8 times 5 is 40. 5 times 4 is 20. And 40 plus 20 is equal to 60. So we have shown that when we plug in 1 to both of those, that this is equal to this. We are then saying that that is a way to show us that these are equivalent expressions. Now, if I look at this, I want you to look all the way at the bottom, because what we have here are 2 ways that you could write a constructing argument statement about this. And in other words, how would you state that these 2 are here? And so the 2 sentence starters that we have is these expressions are equivalent because when I evaluate both for x is equal to, we chose 1, they result in the same simplified value, or they're not equivalent because when I evaluate both for x equals 1, they each result in different simplified values. Now, in this case, the one that we found was that they did result in the same value, so we can say that they're equivalent. This other one was not the one that we actually found, but if we did find that when we plugged in and we got 2 different ones, it would be a good counterexample, something you would have learned about in geometry. If you can show a counterexample, something that shows it's not true, we can state that same thing. But here, that is not the case, so we're in pretty good shape. Now, you did talk about proof at some point in time in geometry, and I will say this. For algebra, this is enough for right now to show us that this is equivalent, and I am fine with this. If we were to say that you have proven for this to be equivalent for all things, it would be a little bit different. And so proof in algebra is It's a little bit more complicated, but I think we've done enough to give us an idea for that. And that's what we wanted to get you guys to today. So with that being said, I am going to share my regular screen and see if maybe I have, I don't know. I probably have nothing here. You know what? I'm going to stop sharing because that's easier. And I'm going to say we have about 2 minutes left. And so, Ms. Morton, if you want to take us back to the presentation, because I couldn't find it because that's the way that I am rolling today, that would be totally fine. But I wanted to give us kind of a chance to sort of see what we needed to do here.
Okay. I threw it in the chat, but this idea of equivalent expressions is actually a really, really big idea. And I want you guys to know that there is value in it outside of Algebra 2. That we need to know when expressions are equivalent and when they are not. Now, we don't often call them expressions, but like you need to know that if you were to add up how many hours you worked each certain day, that should be equivalent to how many hours of work you're getting paid for on a paycheck. Those should be equivalent expressions. And you definitely need to know if those are not equivalent, because if you're working more than what you're getting paid for, that's not cool.
Agreed.
All right. So, look at me go. Wrong way. Okay.
I'm glad you're driving.
Your homework is to finish up worksheet 1.1. It is just questions 4.7. They go with today's notes. Be prepared that tomorrow we are going to be we're going to unlock a quiz for you guys to do. We're calling it a quiz because that's what it's called on Google Classroom. It's an assessment, but it's not like a test. We really just want to know how you guys are doing with this stuff because we need to know if we need to adjust how we are teaching you all. So make sure you guys are doing this work before you get to the quiz tomorrow. Even though it's not due till Sunday, we would really prefer if you got to it now. And I want to make sure I clarify, there was 2 ways that you can work with equivalent fractions today. The first one, we just talked through how you could explain it, that you can simplify an expression and see if the first expression and the one that you ended up with are equal, then we're all good. You'd use a simplifying method. Or in exercise 3, we went through how you could evaluate the same number in both expressions and see if you end up with the same simplified value. There was 2 options today, simplifying route or an evaluating route for figuring out if 2 expressions are equivalent.
And they both work just fine. And so it just depended upon what you're going to do. So I will say, guys, you've been very attentive. We appreciate that. And thank you for participating, and have a lovely day. We will see you tomorrow.
Bye.
Bye, guys.